Hey guys, welcome back to my channel. This is Srini here. So if you're new to this channel, I'll be just giving you a quick brief about this channel. So this is a channel where I'll be creating few videos on Java, Selenium, Python, API automation, robotics process automation. So you'll get a lot of free resources here to learn and understand. At the same time, I'll be concentrating more on the practical part. So you'll be able to clear your technical knowledge as well as skill sets, and you'll be also getting a lot of interview questions on these different topics in my channel. So stay tuned, and if you've not subscribed to my channel yet, I would strongly recommend go ahead and subscribe it, and just hit the bell icon to get notifications. In case you have any queries or if you would want me to take any videos, just leave a comment on my channel. I'll be happy to take it up. So today's topic is on collections in Java. So this is a very important topic in Java which I had to take, and it was quite pending for some time. So I've just found some time to take on this particular topic because I'll be creating one more video which requires this as a prerequisite. So I have to prepare this video first. So collections in Java is such an important topic nowadays, not just for Java interview, but even if you go for any other interview like Selenium automation interview, you would be finding that if you're using Java language as your primary language for doing any framework coding, then this is the most important topic in Java. You may not know other topics, you can still somehow escape in the interview, but from collections you can't escape at all, because collections is such an important topic that guaranteed you can see at least few questions on collection. So that is really a sure thing for collections. So this particular session is going to give you a lot of insight on what is collection, background about it. I'm going to explain this hierarchical diagram of collections, so don't worry much about this for now. And this is just a brief overview session on collections topic. And in the next subsequent sessions, we are going to see in detail about all the different classes which are there in collections, and with some practical examples as well. And I'll be also creating one more video on what all different interview questions you can expect on collections from basic to advanced level. So this video is just going to give insight to any of the people who are not having any idea at all on collections. So it's just a base to start with. So let's get started. So what are collections in Java? So collections is basically like a kind of a framework, you could say, where we have certain inbuilt classes, and those classes have basically implementing some interfaces, and those interfaces have got some methods. So this is a collection of basically the classes, the interfaces, and we will be having some kind of algorithms as to how to use these classes, right? What are the methods within the interfaces? So it's a collection of all such different combinations, like we have the classes, interfaces, algorithms together into a framework. And such a framework has the capacity of doing a lot of different operations, like what? We can store different types of data, we can retrieve the data, we can insert the data, we can delete the data, we can view the data. So it has got a lot of different operations which you can do in a collection. Now you might have ask a question, or you might have such a query in your mind as to why do we need collections? Like what is the background? Like why do we need collections as such in Java? The primary reason for that is that, let's just think of an example. Let me just go to the practical part of it. Let's just say we are having this particular class in Java. Now I'm having a data type int a equal to 10. I'm having another data type b equal to 20. For now, these two are similar. Now it might be a case that we have one more, or let's say like this, there are many variables as such. Okay, so it's basically leading to a lot of different variables creation. Then memory storage would be separate for each and every variable. So it's very cumbersome, and it's not even a proper practical way of doing it in Java. So instead we would say, what could be the intelligent way of doing it, right? The intelligent way of doing it could be to create an array. We can create an integer array and then store the data into that. What we could do, we could create an integer array. So if you are not familiar with the basics of array, you can just try to brush up on the basics, or you can find to how to understand on the array concept. Just try to go over the internet, and even I'll be creating a video on arrays and strings shortly. So this is how the array is declared. You have to mention the data type first. Okay, you have to put this rectangular braces. This indicates it's an array. This is the name of the array, ARR. You're going to use the equal to operator, and you have to allocate memory to your array object. So AR is a reference in the memory, but it is pointing to a memory location which can hold multiple values. But how much multiple values or how many variables is it going to store, that you're going to declare it using this syntax. So what am I trying to say? I'm using the new operator to allocate the memory. How much memory? I'm going to allocate 3 objects of memory. So it can store maximum 3 objects. Maximum 3 values can be stored. And always the array index starts from 0, and it will go till your maximum length of your array, which is 2 here. Now you could argue that we have given the size as 3. Why are we going till 2? Because the length of the array is 3. Size of the array is 3. But always the array index will start from 0. So we are going to have 0, 1, and 2. So these are the 3 different indexes at which you're going to store the 3 values, right? Now, how do we store the value in an array? It's quite simple. You just have to say arr of 0 equal to 10, arr of 1 equal to, let's say, 20, same value, and arr of 2 equal to 30, right? So this solves our primary issue with respect to different variables usage or different memory consumption, right? We can simply eliminate this with this. This is fine. But array is actually index is going to be always fixed. The size is always going to be fixed. You cannot increase the size or you cannot decrease the size dynamically. So what if in future I say that I don't need 3 elements, I just need to actually use only 1 element? So do you create again a new array? No, right? It is basically going to be again wastage of extra space, or creation of new variable will not at all be required as such at this point of time. What we would have liked in this scenario would have been just reduce the size of the array, or you increase the size of the array as per our need. As per whatever situation demands, you increase or dynamically decrease the size of an array. But that is unfortunately not supported by arrays concept. That is why we need some strong type of storing mechanism which will basically not only retrieve the data, insert the data, manipulate the data, but also it will have some intelligence as to if it has to shrink, it will shrink dynamically. If it has to grow, it will grow dynamically, and we can even retrieve the values faster using the similar indexing mechanism, that is 0th index, 1 index, 2nd index, so on. So that kind of mechanism is provided by collections. That is why we use collections as one of the simple example I just thought to illustrate to you all. So what we would get with collections is that it will be dynamic, right? It will be dynamic. That is, size will increase or shrink as per our requirement, whatever we would want to, right? We can of course find out the size dynamically each time using its inbuilt methods. There are classes that have methods. So using those methods, we can determine what is the size of the respective collection type. So that's what we are going to see in detail in this particular session. I mean, just the overview part. And whenever we come across each term in detail, we are going to see it in our next session. So let me just show you what is this particular diagram all about. You have to understand this. This is the most important part in collections topic, to understand the hierarchical diagram. Why it's so important? Because you need to understand what is the relation between the topmost root in the hierarchy, what are the subclasses, what is the interfaces which are being used, which classes are using which interface, which classes are extending which other classes. So it's very important to understand this entire diagram. So I'll not be going quickly, I'll just be taking my time so that you guys will be able to understand each and every part of this topic clearly. Yeah, so let's get started. So it all starts with this particular root element in the hierarchy called as iterable. Now, as the name suggests, iterable means it's an interface. I mentioned in the right hand side, it's an interface such that it would allow to iterate over particular loop, or to give some kind of iteration so that we can go over from the 0th element till the last element and try to iterate it over, right? So it is having some abstract methods. Why we are saying abstract methods here? Because it is an interface. Remember guys, interface is just a template. It is not a class. So it will just have declarations. It will not have any definitions, right? So it will have the iterator method. It will have a list iterator method. So don't be worrying about much of the iterator or list iterator. Just understand that there's an abstract class, or basically it's like an interface. It just has the method declarations, and whatever classes would be implementing this interface, they have to provide definitions for the iterable interface, right? So what is happening here? There is another interface called collections, right? This is also interface, this is also interface, fine, but this, for now, you consider it like it's like an abstract. No classes as such basically are going to use it for now. So for now, collection is the interface extending the iterable interface. That is why if you see here this arrow, the symbol, I've indicated extends. So collections interface extends the iterable interface. That would mean it can add on top of whatever it has got in this iterable interface. It will of course will have to implement those methods, right? Along with that, it can have its own methods as well extra. Now, why do we need that? Because of course, not just iterating, right? There might be so many methods you would be requiring, like to add an element, to find out the size of the collection, to remove the element, to check if a particular element is present in the collection or not. So there are so many different operations, sorting. So there are so many different operations which you would want to perform on a collection, right? So that is given by this collections interface. Whatever generic methods are there, those are provided by the collections interface on top of whatever method it has got from the iterable interface. So it has got some good collection of methods now. But that is not all what we require to have, right? It depends again on what type of collection we are having, what is the need of the hour. Accordingly, there might be a need for more methods as well. That is why, depending upon which type of data storage we require to do and what is the operation which is required from that scenario, we are having widely 4 different sets of interfaces. Now, this is the most important part. We are having a list, we are having a queue, we are having a set, we are having a map. Now, just don't think there are so many things involved. It's very complex. It's a complicated topic. It's very simple. It's just that it's too vast and we have to go step by step. If you try to jump on to any topic without trying to understand each and every element of it, will become too complicated. So just let's go one by one. So let's consider list for now. What is a list, right? As the name indicates, it's a list. It's like a list of books when we say, or a list of articles when we say. It's like a collection. It's like a collection of some articles or books. Fine. If it's a list, it's a collection of something, then what could be the type of the storage, right? That might be the next question which you might be having. So it could be same, it could be different types. So that was another disadvantage in case of array. We had to go with a specific array or a specific particular variable. What was the different disadvantage of that? Because we could either say integer, we could either say double, we could either say string. But in collections, we have a flexibility that we can not only store one type, but we can store different types of elements into one collection. That is the advantage of collections. So a list is something like which will be, it can be ordered, right? It can be unordered. It's just a collection. It will be sequential, of course. Whatever elements you're adding one by one, it will be stored based on the index, right? So that is why we are having these different classes. If you see this straight line and there is a T formed here, again a T formed here, again a T formed here. This is the abbreviation I've used for mentioning that the classes implement the interface. So ArrayList class is a class. That's why I've given here the abbreviation C. C stands for class. ArrayList class implements the list interface. Linked list class is having some more speciality about it. It is also implementing the list interface, right? As the name suggests, linked list, so it's sequential. In whatever ascending order it's going to store. So it's linked list, right? Array list is just like storing the values with respect to the indexing part. Need not be sequential. Then vector. Again, vector is like, you could say a legacy class, which we had earlier in previous versions of Java, like 1.3. Later on, it is not used much. And then we have stack. And if you see an arrow, stack is having an upward arrow towards vector. This indicates that stack is a subclass of its vector superclass, right? So now frequently you might be seeing that we use stack, because vector was a legacy class which was used much earlier in previous versions of Java. Nowadays, if the need be, we use stack, because stack has also got the same features as vector. In addition to that, it has got more methods to work upon, right? So array list, linked list, vector, you might have heard about a lot of these terms, maybe during interview, or maybe during whenever you're trying to work with Selenium, or maybe with Java. Technically, you might have heard these terms. So these are very simple things to understand. When we look at the technical aspect and the practical session, you will be able to get more idea on it. So for now, just stick on to this aspect that these are the different classes which are implementing the list interface. And list interface has got some more methods which will make it a generic that it's a list, and it will work upon that way, right? What is the next interface? Next interface is a queue. So as we know, we have heard about these terms queue a lot, right? And even stack in our C++ days. So unlike stack, which is like last in, first out, right? That's what we call about a stack. Whatever has come last in, it is the first one to be popped out or to be taken out. Queue is first in, first out. You have come in a queue, you are the first one to enter, you are the first one to go out. That is what we have understood from our earlier practical knowledge from our C++ and those OOPS concepts, right? So queue has got two types now, right? So if you have to just see this diagram, if you see there is a DQ, it's an interface. I mentioned the I here, it's an interface. So DQ is one specific type of interface where you can even try to add the elements from the other side of the queue. May not be always from the front side, you can also try to interact from the other side. So there is a specific speciality about this DQ, and it is having some more methods to add on to that, whatever generic methods queue already had. Now, a normal queue, if you are trying to tell that, okay, you are the having a particular queue, which is like a priority queue, this particular thing has this priority, this particular element at this priority. According to the priority, we have to do performance, the operations on those elements within the queue. So we are having a class called priority queue here. This is implementing the queue interface. If you see this T icon here, so it's T. So priority queue is a class implementing the queue interface, and DQ is just extending this queue interface. These both are interfaces, and now you're having a class array DQ, which is just implementing this interface, because this is the updated one. It is already having all the properties of queue, so it just has to implement this DQ, right? So this was the second portion of this particular diagram, that is the queue. Next part is a set. So set is something like a collection, right? So we are going to see different types when we come across the practical part. So I just wanted to keep it simple, so I've shown this particular diagram. Again, a set will be like how we have seen earlier in our days. We used to represent this using a rectangular basis, and we used to store some values. So what we understand by a set is that it will always store unique values. It will not have duplicate values. So that is a speciality of a set, right? The next we are having is a map. So a map is something like, if you have understood this particular term or heard this term before, JSON, it is a key value pair, right? A key and then a key having a value. Similarly, in map, we are going to see a key value pair combination, and we are going to have a lot of different concepts we will be going through. That is hash map. Then we have a linked hash map. Both of these are classes. We have tree map. This is also a class. What is this sorted map? Sorted map, as the name suggests, it is sorted. So it will be sorted in some ascending order. And then we are having a tree map class. So tree map class is a class now implementing the sorted map interface. So this suggests that tree map class would have its elements in the ascending order, right? And hash map and linked hash map, we will see all of these concepts in our practical sessions. It's just that the overview we wanted to give here. So again, just to quickly brief over what we have seen so far in this particular session. Collections is a way of storing the data, iterating over the data, retrieving the data, performing sorting, insertion, deletion, manipulations on the data. It's a very systematic way, and which negates the disadvantages what we had in our other legacy ways of doing it through arrays or storing it individually in different variables. So it gives a lot of flexibility and advantage. it is having some interfaces which are quite powerful, and there are classes which are implementing those interfaces. We have already seen the list of them. So those are list, queue, set, and map interfaces. And what are the classes implementing the list interface? We are having array list, linked list, and vector. And then stack is extending vector. So stack is another class basically which is using the list interface. Similarly for queue, we are having priority queue and array queue. For set, we will be seeing some classes as well. So I'll be mentioning those as well in detail. So those are hash set, linked hash set. So we will go through that. Then in map, we are having hash map, linked hash map, and tree map. So this is such an important portion to understand. And when we start looking at the practical part, you will be getting more comfortable. All of these would be some or the other way used in our Java practical part when we try to create a framework, when we try to work with a different types of, a complicated framework. You will be using collections very widely, and we will be also using this in Selenium when we try to implement a framework. So to achieve a particular purpose, some or the other way, this collections is going to play a critical role. So do stay tuned and look at my upcoming videos on collections. And if you haven't subscribed to my channel yet, I would strongly recommend go ahead and subscribe to it. Thank you so much all.